Question number 3. How to find greatest common divisor of two numbers using recursion. So here, as always, we will start with our first step. So what's our first step? So the first step is to find the recursive case. So the question asks to calculate greatest common divisor of two numbers. So first of all, let's define, well, what is greatest common divisor of two numbers? In mathematics, the greatest common divisor, GCD in short, also known as greatest common denominator, greatest common factor, or highest common factor. So GCD is the largest positive integer that divides the numbers without a remainder. So what does this definition mean? So for example, if you want to calculate the GCD of 8 and 12, it is 4. So one method of finding GCD to find the prime factorization of two numbers. So for 8 we can write 2 multiplied with 2. We are multiplying 2 with itself 3 times, and for 12 we can write it 2 multiplied with 2 multiplied with 3. So here if we take the common values, so for 8 we have 2 common values that we have in 12. So these values are common values. So if you multiply these two values, we will get 4. So this means that GCD of 8 and 12 is 4. So a more efficient to calculate the greatest common value is Euclidean algorithm, which uses the division algorithm in combination with the observation of GCD of two numbers also divides their difference. So if we calculate the GCD of, for example, 48 with 18, the first step we are going to do, we will divide 48 by 18. So if we divide it, we are getting 2 and the remainder is 12. Now in the next step, we are going to divide 18 by 12 and write it like this. So 18 divided by 12 is 1. So the remainder is 6. So in the next step, we are dividing 12 with the remainder, so which is 6. So it's going to be 2 and the remainder is 0. So we are doing it until we reach the remainder as 0. So based on these steps, Euclidean algorithm can be expressed like this. So we are calculating the GCD of A and B. So in case B is 0, so it's A. The GCD of these two numbers is A. In case B is a positive number, then in this case we are calling GCD with B and A mod B. So in this case we are taking remainder over here. So as we did in this step, so every time we are taking B, then the remainder of from the equation A divided by B. So this continues until the remainder reaches the 0. So from this expression we can see that we have expressed our equation on both sides with the GCD method. So this means that we can call it recursively. Now let's switch to Java to write this base condition in our function. So as a first step, I'm going to create our method over here. So it's going to be public int, which will return integer GCD. So it will take two parameters, integer A and integer B. So as a base case, it's going to return GCD with A and A mod B. So this is our method. Now let's see how this is working. So I'll just call our method for 8 and 4 and run this. You see that our method raised an error. It says that division by 0. So this means that our B reached to 0. So our method is not working properly because it reached the 0. So we need to somehow prevent this case from here. So here again, I want you to pause the video to come up with your own answer. In this way, you will understand it very well by comparing just listening. So pause the video and think about it. Alright, let's see how can we prevent this 0 division over here. So here again, we have step 2. So in this case, we need to find the base condition. So in our step 2, we will find base condition, but if we look at carefully to our definition of Euclidean algorithm, you see that here it mentions that when B reaches to 0, we need to return A. So in this case, our base condition will be B equals to 0. So we can implement this in our method. So in our method, as a first if condition, which will be our base condition, we can write like this. If B equals 0, then in this case, according to Euclidean algorithm, we can return A. So this is our method. So now let's run our method one more time to see how it's changed. Now you see that it returns 8 because we did something wrong. So here we need to call as a base condition with the parameter of B, not A. So we did a mistake over here. So I want you to correct this mistake over here. When we are calling recursively, the first parameter is B and the second parameter is A mod B. So if you look at our equation over here, you see that the first parameter is B and the second parameter is A mod B. So I've mistakenly typed an A over here, so that's why it's giving 8, but if we rerun it, you'll see that it should give 4 because the GCD of 8 and 4 is 4. So everything works now fine. Now we know that we have not finished yet because, as you know, we have third step. So in the third step, we need to identify unintentional case. So once again here, I want you to pause the video and think if you can come up with what condition we need to include as a third step over here. Alright, hopefully you have found it. So if you haven't found it, you don't need to worry about it. I'm going to explain it. So here, if we look at carefully to our definition of GCD, it says that it's the largest positive integer number. So this means that we need to prevent the cases when we have negative numbers. So both A and B must be a positive number. So to prevent these cases, we need to write another if condition inside our method. So let's write it over here. So here, before writing our base condition, I will write another if condition which will check A and B. If A is less than 0 or B is less than 0, so for such cases, generally I'm returning -1, so you can return whatever you want. So in this case, we are returning -1. So let's see, for example, run our method with -a to see how this is going to happen. So you see that our method returns -1, so which means that everything works very well. So our 3 steps have been successfully implemented. So everything works smoothly. So with 3 steps, we have implemented recursion for calculating GCD. So alright guys, with this lecture I have explained another interview question related to recursion, which is calculating the greatest common divisor of two numbers. Now let's continue to the question number 4.